Hi, welcome back to Mind Maths with Amina. Today I'm going to solve the sample examination questions given in the Mathematics 1 study guide given by University of London for their EMFSS courses. The first question says, a monopoly producing a quantity Q of product has a total cost function given as follows. Okay. The total cost as a function of quantity is Q raised to power 3 plus 4Q plus a 10. The demand equation is given as follows. Okay, P D as a function of Q is 20 minus a Q. So therefore, total revenue as a function of quantity is going to be price as a function of quantity multiplied by quantity. So we have a 20 minus Q multiplied by Q. We have a 20Q minus Q square. So the profit function in terms of quantity is going to be total revenue in terms of quantity minus the total cost in terms of quantity. So we have a 20Q minus Q square minus Q raised to power 3 minus 4Q minus a 10. We can simplify this and we'll be left with minus Q raised to power 3 minus Q raised to power 2 plus a 16Q minus a 10. We want to determine the quantity which maximizes profit. So we need to take the derivative with respect to quantity and then put it equals to a 0. We'll have a minus 3Q square minus 2Q plus a 16 and we want to put it equals to a 0. We'll have and we also actually need to take the second derivative and we want to see that at the optimal quantity it should be negative. This is the requirement. The second derivative of this function is a minus 6Q minus 2. So let's find the optimal quantity. The optimal quantity is the first derivative is equals to a 0. This was the first derivative. I'm going to put it equals to a 0. And we have the following quadratic equation. When we can use the quadratic formula to solve this, where A is equals to a 3 and B is equals to a 2 and C is equals to a minus 16. So the value of quantity is a minus B plus minus B square minus 4AC over a 2A. So once you solve this, one answer that you're going to get is a minus 8 over a 3. And this is negative, so therefore this is an invalid solution. The other quantity that you're going to get is 2 and this is positive, so therefore this is going to be the optimal quantity which maximizes profit. We need to verify that the double derivative is in fact negative at this quantity. So we plug in this quantity and we'll get a minus 12 minus 2, which is a minus 14, and therefore it is negative. So yes, the profit function is being maximized at quantity 2. That's all they asked in this question. The next is a firm is a monopoly and it has fixed costs of 5. The average variable cost, which we know is variable cost over quantity, is given as Q power 4 minus Q minus 5Q square. We also know that the total cost function is fixed cost plus the variable cost. So from this equation, we can tell that the variable cost after cross multiplying, we are going to get a Q power 5 minus Q power square minus 5Q power 3. So the total cost function becomes a 5 plus Q power 5, Q power 2 and Q power 3. Okay. They've also given us the price as a function of quantity, which is 20 minus q. So from here we can find the total revenue function, which is price into quantity. So we are just going to get a 20 minus q multiplied by a q, which is a 20q minus a q square. So again, they want us to first find the expression for the firm's profit. The profit as a function of quantity is simply, again, total revenue minus total cost. The total revenue is 20q minus q square, and total cost is 5 minus q power 5 plus q power square plus 5q power 3. We can simplify this cancels out. Yeah, and we cannot further simplify this. So the profit function is a 20q minus 5 minus q power 5 plus 5q power 3. They also want us to determine the production level that maximizes profit. So we need the first derivative, which is a 20 minus 5q power 4 plus 15q square. Okay, and we need to put it equals to a 0. We are also interested in the second derivative, which is a minus 20q power 3 plus a 30q, and we want this to be actually equals to a 0. So what we can do now is we need to solve this equation. We need to solve this, and let me add another page here. Okay, so we have oh, actually we can divide this through by -5. First, let's write it like this: 5 q power 4 minus a 15q power 2 minus a 20 is equals to a 0. Dividing through by a 5 will give us a 5 ones are 5, 5 threes 15, 5 4s are 20. We can make a substitution. We can say suppose q square is equals to an x, which would mean that q power 4 is just going to be an x square. So we'll get an x square minus 3x minus 4, and we can therefore implement the quadratic formula where a is equals to a 1 and b is equals to a minus 3 and c is equals to a minus 4. So x becomes a minus b plus minus b square. B square is a 9 minus 4ac over a 2a. So we have a 3 plus minus 9 plus a 16. So a 9 plus a 16 is a 25, I guess. Yeah, over a 2, and x was actually a q square, right? So we have a q square is equals to 3 plus minus 5 5s are 25 over 2. Remember, we cannot have negative quantities, so the only valid solution would be a 3 plus a 5 over 2. So we have a 5 6 7 8 over a 2, which is a 4. So quantity is going to be a plus minus under root of a 4, and since only positive numbers are allowed, so this is just going to be a 2. So therefore the quantity at which profit is being maximized is going to be 2, but we need to verify that the double derivative at this quantity is negative. So we need to make sure that when I put the value of q as being 2 here, I am going to get a negative number. So 30 multiplied by a 2. So we'll have, actually this is a negative number. So yeah, we do have a quantity that is maximizing profit. Okay, moving on to the next one. Find the critical points of the function given by this. Okay, the function is a 3x4 plus 4x cube minus 12x square plus 20. So we take the derivative and we want to put it equals to a 0. So the derivative is 12x power 3 plus 12x power 2 minus 24x is equals to a 0. Or we could just do that in this second line. We need to put the derivative and put it equals to a 0. So that means we want to take this expression and we need to put it equals to a 0. I can take 12x out as common, which will give me an x square plus an x minus a 2, right? So this gives us a 12x. 12, actually a 12 cannot be equals to a 0, right? So one solution is x being equals to a 0, and the second solution is this whole expression being equals to a 0. So this you can factorize it. We know the two ones are 2, right? So 2 minus a 1 is going to give us a 1. So we have an x plus a 2 minus 1, x plus a 2. If we take x plus 2 as common from the first, we'll get an x, from the second we'll get a minus 1. So this gives us x is equals to minus 2 and x is equals to a 1. So we have 3 critical points. One at x is equals to 0, one at x is equals to minus 2, and one at x is equals to a 1. So we need to verify whether each of them, we need to classify these points. So let's do that. We have the first derivative calculated already. The way we can classify these points is by taking the second derivative. Okay, so the second derivative is going to be a 36, x power 2 plus 24x minus a 12, 24. And when we plug in the value 0, we'll get a minus 24, and this is negative. So that means our function at x star is equals to 0 is being maximized because the double derivative at this point is negative. Okay. The second derivative at x is equals to a 1 is going to be 36 plus a 24 minus a 24, which is a 36 greater than 0. So therefore, when x star critical point is equals to a 1, we have a minimum point. So lastly, when the double derivative is seen at the critical point minus 2, we're going to get a 36 into 4 minus 24. Basically it's a plus here, but we are multiplying it with my minus 2. So this is actually going to be positive number. Yeah, it's going to be a positive number. So therefore x star is equals to a minus 2 is just a minimum point. So we've classified all of these. I think this is the last question for today's video. The function is given by this. So there are two functions of x being multiplied. So in order to find the first derivative, to find the critical points, we'll have to take the use the product rule. So the function is a first function of x being multiplied by another function of x. So as a recall, when you have two functions u and v of x, then the derivative of f with respect to x is one function as it is, and derivative of the other with respect to x plus then the other as it is, and the first the derivative of first with respect to x. So let's do this. Derivative of f with respect to x will be one of these functions as itself multiplied by the derivative of the other plus the second one as it is, and then the derivative of the first. Simple. Okay, we can take minus e power x minus x as it is as common, and then we have this from the first expression, and we'll have a minus 2x minus a 10 from the other expression. Okay, so then we have remember that, oh, let's just simplify this first before I put it equals to a 0. We'll have a x squared plus 8x minus a 20. And since the function ex or e minus x is always positive, the only way the first derivative can be equals to a 0 is if this function equals 0. So we require this to be 0 at the critical point. Now we can use the quadratic formula. Actually, we know 2 tens are 20, right? So we can just factorize it instead of using the quadratic formula. We'll have 10x minus a 2x, which should give us the answer. So the roots are going to be x plus 10 and multiply by x minus 2 is equals to a 0. So the stationary point is going to be at x minus 10 and at a x2. So we need to classify these. For that, we'll have to take the derivative again. So the first derivative was this expression. So we need to take the derivative one more time in order to classify these points. We're going to use the product rule once again. So e minus ex as it is into the derivative of the expression next to it, which is 2x plus 8. And then we put a plus sign, and then the second expression as it is multiplied by the derivative. So a minus into minus is a positive, so we're going to be left with this. Okay, if I take e minus x outside, we'll have a 2x plus 8 and a minus x squared minus 8x plus a 20. Okay, then we have a e minus ex, and then we have a minus x squared minus 6x plus a 28. Okay, so let's find out. I hope I didn't make any mistakes here, though I feel quite suspicious right now. Okay, the second derivative at a 2. Okay, actually we know that this is a positive number, right? So the derivative at 2 depends on this quantity. So let's just multiply it, the bracket, let's just put the minus inside, so it's going to become easier. So e x, so I'm just taking the negative sign inside. So now the sign of the double derivative, since this is positive, the sign of the second derivative depends on the value of this function. So the double derivative at a 2, it was a 2, right, is going to be, I don't need a calculator. I know e minus 2 is a positive number, and over here I have a 4 plus 16, no, 12, 6 2s are 12, minus a 28. So yeah, a 16 minus a 28 is definitely a negative number. So the whole second derivative is going to be negative. So that means this is going to give us a maximum point. Let's see the value of the double derivative at 10. E minus 10 is a positive number. Then we have 100 here, minus a 60 here, minus a 28. A 40 minus a 28 is actually a positive number, right? This expression right here. So we have a positive number, so this is a minimum point. Yeah. So I just wanted to solve 4 questions per video. In the next video, I'll continue solving the sample examination questions given in the mathematics study guide. I hope this was helpful and have a nice day. Take care for now.